What a wonderful afternoon, or what a wonderful day to all of you who are tuned in today from around the globe. I want to see all of your good day, good afternoon. I can see a lot of people who are logging in right now, who are tuning in to our very first Lean Manufacturing 4.0 mini virtual summit. What a wonderful day, everyone, from PSQ Nation. Let me see some of your comments right here in the chat box. I can see in here. Hi, Aini. Thank you for tuning in. Good afternoon, everyone. I can also see in here Celine. Hi, Rosel from Dagupan. Can you also type in where you're from, where you're dialing in from right now? Let me see. Natalie. Thank you for tuning in. Hi, Bianca. I can also see in here Paul. Looks like we have some folks from Colegio de Dagupan. Thank you for tuning in. Good afternoon. I can also see, how about from the others? I can also see from Malaysia. Wow, from Dindin. I can also see from Melaka, Malaysia, Celine. That's Celine Wong. Another one from also from Malaysia. I can also see in here Wasab from Saudi. Another one from Colegio de Dagupan. What a wonderful day. From the Philippines, Romy. Hi, Romy. Thanks for joining. Student. Okay, I can see in here one of our speakers. You can also see in here from Nord International Distributors. Thank you, Neri, for joining. All right, so there's a lot more. I can see a lot of comments right here in the chat box. So thank you for making it as overwhelming as possible. Thank you for the interaction. I can see a lot more comments. All right, that's amazing. That's amazing. Great afternoon from everyone. Without further ado, I want to introduce to you our first speaker for the Lean Manufacturing 4.0, so that you won't be missing anything. You would be maximizing the 2 hour summit that we designed for all of you. So, our first speaker is a visionary leader bringing in a rear level business acumen with a track record of driving businesses and delivering management solutions to carve niche in global markets. Our speaker has reached strategic management with 20 plus years of experience with international exposure at Fortune 500 corporation at China, Southeast Asia, and North America. Currently, our speaker is working as a regional director for engineering, manufacturing, and quality at General Motors, North Africa. North Africa or America. Shady's efforts and accomplishments resulted in being honored as the recipient of 5 global prestigious awards. Wow, such as 2019 Global Quality Leaders Award, 2018 Middle East and Africa Quality Excellence Award, 2016 Global Quality Professional of the Year from American Society for Quality or ASQ, and 2012 Young Industry Leadership Award from Society of Automotive Engineering, and 2013 Quality Innovation Award by Asia Confederation of Business. Without further ado, our first speaker from Egypt is no other than Shady Bahir El Safti. Hi, Shady. Good
Good day.
afternoon.
Hi, how are you? Good day for all participants today. So today I will start my presentation about Lean 4.0 roadmap, and I need to thank Philippine Society of Quality PSQ because this very important topic and become one of the very trending and important topics that we need to discuss. But also in the beginning, I would like to share some information about myself. This will be help you for you Q&A if you need to ask a specific question. Through my career, I try to have diversified experience in different university and study from US, South Korea, German university, a lot of certification. So all my career, I try to do this balance between process management, and people management. So I'm certified as Red X Master. I'm certified as Master Black Belt of Six Sigma, and spent all my career working on improving lean implementation and understanding all over the world. And if you see the photo, this one of nice photo for me. I always like in Philippines when I was invited in a conference in 2016 with PSQ, is one of very interesting and valuable and dynamic group of quality professionals that I always happy to join. So what I will try to discuss with you today, and please feel free at the end in the Q&A session to ask whenever you like, or to highlight on some of your experience, sharing also some best practice, because I always try to learn from the summits and careers that I always join. So what I would like to share with you today is the history of industry from 1.0 to 4.0. We need to understand what is the change and how this change happened, so we can be ready with all the tools and processes. How smart factory look like? Many of us now working in some smart factory, but also all of us is experience smart products. There is a lot of smart product today in the market, so we need to understand how it look like and how the lean can help us to produce good quality smart product. I will talk about Lean 4.0 roadmap, Lean 4.0 value and business opportunity, and how, which is the important model, 7 types of waste in Lean 4.0, how we can solve this or eliminate this type of waste. And of course, we can go all together through the conclusion, what we can reflect and implement in all our business and all our nations. These very important 3 questions. So at the end of my presentation today, I would like to answer this question, and through the whole presentation, we will have answer for this question. One of the most important questions I always have been asked in any conference or summit with my experience in lean manufacturing: will Industry 4.0 replace lean, or can they coexist? Are lean and Industry 4.0 technical or technology can be compatible together? Can lean cope with digital era and evolve? How this lean can be evolved to 4.0? Through our presentation, we can answer together these 3 questions, which I believe very, very important. So this is the history for 1.0 to Industry 4.0. I'm sure that all of you have this kind of experience, but we need to discuss together because this is very important from degree of complexity. First, the Industrial Revolution 1.0 start in 1800 with the first mechanical loom in 1784 through introduction of mechanical production facility. Another industrial revolution in 1900, and this industrial revolution focused on division of labor and mass production, with all what happened with Henry Ford and all his kind of mass production, with help, of course, of electrical energy, having first assembly line. When we go for third industrial revolution, and this third industrial revolution is based on the use of electronic and IT systems that can further automate the process. And this is the most important, with the first programmable logical controller BLC in 1969. And finally, now what we are facing now is the fourth industrial revolution through the use of cyber physical system. And I believe now the expert don't talk about Industry 4.0 anymore, but they talk about Industry X.0 as the revolution is every day with this kind of technology and this increase in the technology. I believe the revolution will be every day, and the trend of changing is increasing dramatically. So there is a lot of complexity on the revolution, and what we will tackle today is the 4.0. So this is a smart factory. Many of you are working maybe in one of this kind of smart factory, and also this applicable on service field. So if you see these features of smart factories, full of sensors, where we can sense and take inputs for data, where we start to rely more into 3D printing and additive manufacturing, some advanced material. Many plants today working with some robot or cobot and digital twin, mass customization. So all this should be integrated together with collecting the data through the big data and with cloud computing. And one of the risks today, where this is very critical and you need always to consider with 1.0, the risk today is the cybersecurity. To have this smart factory in the industry 4.0 with this all sensor and robotics and integrated system with Internet of Things, mass communication, big data applied on cloud computing, we will always face the high risk for cyber security. And this is one of the disadvantage or the risk accompanied or associated with industry 4.0. If we see this through the four wall of the plan, please consider how to integrate your system with the supply base and also logistics, and start to have this kind of logistics also 4.0, and supplier management, dealer management should be all integrated together. So if we talk about the smart product, today there is some four features. These features in every smart product. The product is aware, equipped with some sensor technology giving the access condition information. The product is smart, equipped with some computing power and autonomous decision making. And you can see kind of autonomous car now with some trial in some country. This product also have response. It can respond to like voice command, for example. And one of the most important feature for a smart product is always connected. I always try and like to share this quote about Mary Barra, the CEO of General Motors, and Mary is one of the leaders who's shaping the future of mobility in the world. And what Mary is talking about, the auto industry will change more in the next 5 to 10 years than what it has been changed in the last 50 years, in 1950 to 2000, these 50 years. So the change will be dramatically. And we need to be ready. We need to be ready for this change with all the tools, with all processes. So what is Lean 4.0? Lean 4.0 is closely alignment between lean management system with all these features we talk about in Industry 4.0. We have all the lean tools, which is well known as Kanban or visual management, or all this kind, and on TPM, all this kind of toolbox of lean and industry technology, Internet of Things, big data and data analytics. How we align both together, and this can be compatible together and evolve as Lean 4.0. And this Lean 4.0 will help us to improve enterprise efficiency, performance, and innovation. However, much of the market is not focusing on Lean 4.0, and I believe this is the objective today of our summit. And this I always thank the PSQ for selecting these topics, that we need to focus more on Lean 4.0, since many practitioners still trying to solve yesterday problem in efficiency, and they are missing the opportunity to evolve for Lean 0.0. The system is fragmented, manual metrics calculation, and practitioner also independently performing lean management in silos with minimal cross-function ownership and ineffective supplier communication. So the main objective today, how to highlight and shed the light on the importance of 4.0 or Lean 4.0 and how we can use it to improve enterprise efficiency, and is very important to improve and rely on innovation. Sometimes in Lean, we talk about continuous improvement, and this is the main philosophy of Lean, but sometimes you cannot improve candle to electricity and light. You need to mix some radical innovation on the system. And this good about Industry 4.0, Internet of Things, data analytics, all this kind of technology and digitalization will be the innovation that will take lean management to lean 4.0. So this slide is a master slide today in my presentation. The blue curve in the bottom of the chart shows a normal and traditional lean optimization curve, where you can see how we can learn, sometimes reduce in the beginning, reduce the waste and eliminate the waste. Then we can go through Six Sigma journey to eliminate the variation, and we keep optimizing the process through traditional lean tool. And this we can see on the blue curve down. But there is some complexity barrier. As I told you, there's a lot of complexity now with future factory and digitalization and the customer behavior and customer requirement. And this complexity barrier, as you see, need or require innovation, which is Lean 4.0, where we can use quality sensing and detection to improve quality. We cannot use manual inspection anymore. We need to rely more on cameras, on visual inspection to ensure error proofing, because consumer behavior now is different than 20 years before. Consumer protection agencies, there's a lot of pressure, social media, all this will put a lot of pressure on quality. So traditional quality in lean or traditional lean tools to improve quality will not help us anymore. Factory asset intelligence, as you see, all this automation and sensing, they cannot working in silos. They all need to be integrated together through factory asset intelligence. With all dynamics, you see, there is a lot of issue, and I believe I will share with you some example from Egypt in the Suez Canal. In almost 2 months before ago, we have some issue with the Suez Canal, and you can see evergreen, and I believe you read about this in the newspaper and the media. So this dynamic in the transportation need very strong dynamic scheduling and managing the supply base, including all the crises worldwide in transportation. So scheduling need to be dynamic. Digital manufacturing transformation, how to optimize this curve. And you see COVID-19 also another pandemic that can show how we can manage our workforce through several tools. And I see one of the best practice I would like to share today. During COVID-19, in some of the manufacturing facilities that I visited, they use some visual system to ensure the social distance between the workers. So the work density in some cell or some station have been controlled through some monitoring system with some barcode, so they can track the mobile equipment or some RFID or barcode with operator, so to ensure the social distance. This is how technology and Lean 4.0 can help. And at the end, we need to ensure that we have strong cybersecurity and we manage the plant energy in a very efficient way. So this requirement and complexity of the product and the factory today need this Lean 4.0 and to optimize the manufacturing process through new advanced tool rather than classical or traditional tool. And this curve I have been adopted from Deloitte analysis. How we convince our senior leadership with this investment in Lean 4.0 and how we convince our senior leader. And I think this is one of the most challenging us as expert consultant in the field of quality, how to go to the senior leadership with the business case, how we convince them and negotiate with them the implementation of some specific tool or investment. This analysis also done by Deloitte about Lean 4.0 value and business opportunity. And as you see from the pillars, the 4 pillars we have improved asset efficiency from 10 to 20% optimization in capacity, asset utilization, change over time. Change over time was not the big challenge 20 or 30 years ago, because now the customer need customized product. You can go through your mobile app and through internet and you request some car with some seat color different than the other car. So change over time was a challenge, but Lean 4.0 can help to reduce this challenge 10 to 20%. Quality, as I mentioned, the statistics show it can be improved from 10 to 35% based on the automation using image processing. Now, many factories that I visit and I see use very strong image processing to control the quality, reduce the scrap rate and the lead time. And both asset efficiency and quality can improve overall equipment effectiveness. If we go to the third pillar, which is reduce the cost by 20 or 30%, labor cost also rely on automation. Sourcing, you can see now you cannot source from only one, three, four, five supplier. You need to go through strategic sourcing. If there is financial issue or bankrupted supplier, you need to have dynamic sourcing, and you need to reduce this kind of sourcing cost. Of course, warranty is another critical for cost. And at the end, and I believe this challenge we have now in every country all over the world, is to improve safety and sustainability. And Lean can 4.0, how to integrate these tools, can improve the safety incident. And I believe this is our top priority in every organization we are working in, to reduce the safety incidents, to ensure the safety of our human team and colleagues. Improve employee satisfaction, and employee satisfaction is very important to improve the performance. People are more engaged. Sustainability and environmental impact. So I believe this slide will be helpful for you when you go and share with senior leadership, with your board, that we need to have this kind of roadmap for 4.0 and have all the required budget support from senior leadership. But what's happening today? And this some statistics show who manages the Lean, and I think this important and eye-opener for me when I see this graph for the first time. Who leads Lean 4.0? Information technology. And what's different between blue and green? So blue is manufacturing and green is a service facility. So now information technology, MIT, all these are taking the lead for improving or managing 4.0. But I disagree on this. This shouldn't be happening. This is the current status. But Lean 4.0 is not about technology. It's not a story about technology. It's about how technology improves culture, collaboration, competency, and leadership. Every department needs to think what tools they are using from Lean management system and how they can evolve and integrate the Industry 4.0 tools. And this graph, I think all of you know, and this is one of the basics, fundamentals of Lean management system, which is a 7 type of waste. But how we can use this technology and how 4.0, Lean 4.0, rely on IoT, Internet of Things, digitalization, to eliminate 7 types of waste. If we talk about the defect, which is one of major waste in our current system, as I mentioned, image processing and using camera on the verification station or quality gates will help us to ensure product and process quality. And some manufacturing facilities use the blockchain technology for traceability of warranty and supplier management. If we talk about another waste with over-processing and the different processing between station and station, we can utilize digital twin and link the robots together from one station to one station to ensure there is no over-processing. If we talk about movement, time and motion study, and all of you know this basics tool when we have new process and try to make this kind of motion study and calculate the time. Now we can use augmented reality and virtual reality simulation even before we hire the people or train the people. We can use this kind of simulation to see the movement and study the movement and ensure zero unnecessary movement or non-value added. So one of really very good practice today, what we are doing is to use this kind of VR simulation to study the movement and the motion during the design of the process, and also during the training. We use this VR to train the operator to see the plant even before he comes, using auto ID technology as RFID sensor. And for overproduction, use real time of value stream, is not using value stream as what we are doing before and we start to write and drawing this kind of value stream. We use dynamic value stream and real time value stream to ensure capacity utilization and also real time visibility of the inventory. So I just try in this slide to shed the light on how this technology, Internet of Things, and digitalization can help us to find solution, more effective, low cost, and reliable solution to eliminate these 7 types of waste, which are available in every time and in every organization. We have these types of waste, and we need to focus how we eliminate through this kind of technology. Another involvement, another evolved for Lean 4.0 tool. And this another example that I would like to share on 3 of the main pillar of Lean system, which is campaign, total productive maintenance, TPN, and Hijonka, which is Japanese term for scheduling. For campaign, of course, using this kind of card and how you write all this, how we use auto ID technology, as I mentioned, to track unit and level consumption. How we can use digital twin or machine learning to simulate campaign bin quantity. If we talk about productive maintenance, rather than talking about this kind of routine maintenance is not having anymore, we rely on machine learning to enable predictive maintenance. And this predictive maintenance will help us to extend the maintenance interval and reduce the mean time between failure or MTTF. If we talk about Hijenka, advanced data analytics stabilize the planning by using historical data and optimize scheduling based on machine availability. So this will help us to keep utilize our machine that time or tool. Every tool can be just an example that I would like to share with you, but of course we have a lot of examples, and I encourage you to search through internet about best practice on the YouTube. What is the best practice for Lean 4.0? There is a lot of best practice. But I always say, talking is easier than implementing, and this is the most important part for Lean. If now I try to implement 4.0, Lean 4.0, I need to be sure that I have framework, standard framework. Of course, there is different framework you can use, but this is one of the frameworks that I would like to share with you today. So this framework divided into 3 parts. The first part is people, which is the basics and the foundation for Lean. Then we go through technology. Then we go through the process. If we talk about people, we have culture, leadership, competency, collaboration. And I believe these 4 need to be led by HR department and function. Then if we go through the technology, data, analytics, app development, connectivity, and scalability. And this need to be led by function expertise in manufacturing engineering, quality engineering, not only IT. Each function owner need to define how we can migrate and utilize this IoT. Then we go through the process, and the most important in the process, to have integrated management system, including lesson learned, including roles and responsibility and monitoring performance, rigid system. And finally, in any system, we need to ensure the compliance on daily basis, on operation, in every task we are doing, we need to ensure compliance to the system. And I believe this one of this advantage of lean versus Six Sigma long time ago, that Six Sigma have very structured way of implementation, even very well structured way of training. If you go through the belt system of training, green belt, black belt, master black belt, we don't have this in lean. So what I try to shed the light today and attract your attention in the implementation, we need to implement through system and through solid framework. And this framework can be changed or different from one organization to one organization, from one country to one country, based on some specific country and industry requirement. So what I would share with you today in the framework is not obligation or is not mandatory, but just practice that I see and I work in. So I believe it's good as use case that you can use in your organization. So if we go to the people part, culture, 30% of companies cite a lack of culture of lean as a top challenge. Only 15% of cross-function team clearly understand how lean contribute to strategic success. And this is our role as a practitioner, how to link between the lean tool and strategic success. If you talk about leadership, only 15% of companies say lean is priority to top management, and lean need to be up-down. Only 35 says that lean is critical for customer satisfaction. Only 35 is very critical now to customer. And only 20% says lean function has a clear and compelling role in delivering corporate strategy. So these statistics have been done in almost 200 companies, and I would like to share this because this will help us in the diagnosis in our company. And these graphs show two different management styles. One management style focus on compliance objective. And one style focus to work in our organization. Compliance is important, but how to link the tool to the performance is the main objective for this session. So you can see with organization with compliance objective, the rates are low. Automated risk management with software, likelihood to adoption 33%, but likelihood increased to 164% to organization working with performance objectives. So what I would like to say here, we need to focus on management by objective. We need to explain as a leaders to our team what is the objective, why we're using this tool, why we're using blockchain and traceability, because the cost of recall is very, very expensive. So if we talk about competency, and this another critical for us, we need to focus on experience, expertise, appraisal, and management. And we need to integrate this system together. 50% of companies say employee training is one of the most critical process areas. 35% have automated training system. Especially now, during the COVID, become very important to utilize automated training management system, rely online and virtual training. And you can see us today. It's very, very good example. Today we have this virtual summit. 5 or 6 years ago, I have to travel to Manila and Philippines to give this kind of speech or session. So we need to ensure now when we are designing the training system to develop the competency of our team to rely more and migrate into automated training management system, virtual training. And even if we don't develop one for our system, we can rely on a lot of ready-made or web-based systems that we can use. I talk about VR. VR, one of the important tools and best practice, virtual reality and augmented reality to train. Today, when we have one new employee in our company, how we can use this VR to train him and make this kind of onboarding experience. This slide is another important slide, is the key today, how we improve the competency. And I believe you are interested in, and I will need to spend few minutes on this slide, especially for our new generation and young generation, for our hiring manager. This is the top 10 skills for 2025 by World Economic Forum. This is the latest update that I have. The top 10 skills have completely changed. If you compare this to 2015, 10 years difference is completely changed. In 2015, we don't have quality management or quality anymore in the skill required in 2025. Why we don't have this skill? Because we have problem solving, we have robust process, we have VR, we have digital and image processing. We don't need. We need now employees with analytical skills. The top skill now is analytical thinking and innovation, active learning, complex problem solving, social influence. And this important here, leadership and social influence, and they put both of them together. Because now having this kind of social influence and emotional intelligence can take the organization to the next level and keep your competitive advantage. Resilience, stress tolerance, all this kind of technology is really stressful. How to have this kind of stress tolerance. And one of the topics we talked during this COVID-19 pandemic is stress tolerance and flexibility. People are very stressed during this pandemic, how they deliver their KPI and the scorecard. But after a few months, people start to have this kind of stress tolerance and flexibility, and now we can deliver. I believe this slide is very important, and I hope you can share with your colleague in the company. We use your HR department, I'm sure is available in many organizations, but we need to keep highlighting on the skill change. As a HR team working now, they need to prepare the skill set need for the future. How we talk about data analytics as one of another important skill for the future. We go through collaboration, and this is the last part of social media have application to improve competency and lean quality culture, enterprise efficiency, as I talk about blockchain in supplier management and traceability. This kind of collaboration is very critical for 4.0 management, as lean is by nature cross-function. One of the best practice I see many organizations I visit in Brazil, in South Korea, we don't have lean function, we don't have lean manager. Lean is a part of the DNA in the organization. Quality manager have role in the lean. HR manager have role on the lean management. So usually in effective and efficient organization, we don't have lean department. So this kind of collaboration is very important, and we need to rely on a lot of technology. And this collaboration not within the organization, on the four wall of the organization. This collaboration need to go through the supplier, need to go through the dealer, we need to go through all integrated systems. If we talk about technology, technology is very important, and data is very important. And when we talk about data, we need to talk about volume, variety, velocity of data, transparency. In many plants, we have the data, but we have big issue on the velocity. So we need to be sure that we have this kind of variety, volume from low to high. Variety should be structured, semi-structured, unstructured, velocity, transparency. Some organizations don't have this transparency of data. If we talk about data analytics, we go through descriptive, diagnostic, predictive, and prescriptive, different types of analytics. And you can see now, even in several manufacturing facilities that I work in, you have the robotic system give all the required information through mobile app, and even it can create the work order if there is some predictive. talk about the pillar number 3. If there is some predictive failure will happen in the robot will connect directly or contact directly his manufacturing, and he issue a work order. This is not a dream or not a wish list. This is happening now in different facilities. The system is integrated and is integrated to the manufacturing of the tooling and equipment and linked and connected together. As I mentioned in the first or second slide, that the product now is connected all the time. App development. And app development, and you can use on our personal life, but it's very important to keep using also. And you can see some wearable you can use on your hand. During the COVID-19, we use in many facilities so we can track the distance and social distance and give some alert to the management team. App development is very important and increasingly powerful to enabler of collaboration, competency, and efficiency. Also play an important role in delivery of intelligence, participation, and adoption. As I talk about connectivity, we need to ensure that we are connected all the time, connected to our people. And this happening now during this kind of pandemic. Most of the organization now, especially service organization, work through at home. You can see that in the stock market, some software and some apps increased dramatically. The demand increased, like Zoom, for example, increased and get a lot of benefit during this kind of pandemic. Microsoft Team, a lot of program and software help us in our organization to keep connected to our team, connecting to our product, connected to our processes. Connectivity is one of the key to keep and ensure Lean 4.0. If I need to talk about scalability, and one of lesson learned for me myself, when we design system for data, we need to consider the scale. Is a global organization, global scale. Even if you talk about license for some machine, we need to ensure, or software, we need to ensure that we have this license is a multi-user, multi-sites, multi-country. What is the future country? So some organization fail using the digitalization because the scalability is not built as expected based on the strategy. So finally, if we talk about the process, we need to ensure, as I mentioned in the beginning, that all value chain is integrated. We have supplier. We cannot make a strong quality system and strong effective campaign, and the supplier don't have. So we need to link to our supplier. We need to link to our dealer, and we need to ensure that all the information is integrated together. When I have some sales request, this sales request go to my supplier so he can prepare the part. So the system is integrated. And as I mentioned in the 7 type of waste, there is no waiting time. In our facility, in our supplier facility, in our dealer facility, no waiting time, no over processing. And we have a strong lesson learned system to keep evolving. This evolvement, as I told you, will not stop into Industry 4.0. We have Industry 5.0, Industry 6.0. We have now Industry X.0. Now I'm reach the conclusion. I do my best to keep the time. So this is my recommendation today in the end of this session, and I hope you can, in the Q&A, I hear from you and listen from you. I see a lot of experts all over the globe. I see strong practitioner, and I also open for feedback. Lean 4.0 is the digitalization of Lean tools. Leveraging the digital transformation initiative, people and process are important to all areas. So we need to utilize digital transformation to migrate from traditional Lean to Lean 4.0. Lean is not obsolete, but Lean have opportunity to be evolved, to use all this technology and digitalization to be more effective and increase the efficiency. We need to recognize the reality and powerful potential of Lean 4.0 on enterprise performance. And this is our role. The slide I showed to you for cost reduction, we need to share and be very confident when they discuss the business case for senior leadership and the board to convince them with our point of view and to construct the roadmap for Lean 4.0. Align 4.0 objective around corporate strategy and develop and communicate and gain support for execution. So this is a question I raised in the beginning of my presentation.
Looks like our speaker has some connectivity challenges. Let me wait for him for a couple of seconds. Yeah, just experiencing some connectivity issues at this point, but so I encourage everyone, by the way, to jot down all of your questions right there in the chat box. I can see a lot of great insights and comments, and I can see a lot of people from around the globe who are with us today. But definitely, our speaker will be logging in a few seconds to wrap up the Lean 4.0 roadmap. So that's his topic for today. So great insights, definitely. So while we wait for Shady, I'll be flashing in here a couple of commercials from the Philippine Society for Equality. The first one is all about the PSQ Excellence Awards. So feel free to nominate your organizations, or if you believe that you have some great best practices or projects in your organization, then you can join in the PSQ Excellence Awards. All right, so our speaker is here with our today. Again, okay. Hi, Shady.
Hello, I'm back. Sorry for this disconnection.
No worries, no worries. We totally understand. That's something normal at this point. So let me check some here. Checking our chat box some of the questions. I can see a great slide on the technologies that are available to eliminate the 7 types of waste. There's a question right here that I can see. Or I can see in here you still need to wrap up, I believe. Or do you wanna finish it first? Okay.
No, I just need to talk about this slide, Ray, because it was very important
Okay.
slide
Absolutely.
for me that I would like to close with, especially with Jack Walsh, the legendary CEO of General Electric. If you don't have a competitive advantage, don't compete. And this is very important. And I believe having 4.0 or Lean 4.0 as a competitive advantage is very important. And as Philip Coulter also defines a competitor is our ability to perform in one or more way that your competitor cannot or will not match. So I believe 4.0 is real competitive advantage if we focus on effective implementation and align the strategy with the performance. Thank you, Ray, and thank for the team, and really appreciate the time and your attention.
Thank you so much, Shady. Great insights. Thank you so much. There's a lot of things that I believe our audience can take away from this very short session. But I know that there's a lot of things that they can get when they go back to their organization. So we can entertain maybe a couple of questions right here. I can see right now. Um, all right, so this is the question. Um, all right, amazing roadmap, Sir Shady from VP. Is there available instrument or questionnaire that we can use to assess our readiness to Lean 4.0?
Yes, there is several questionnaire, and I think this is very good. But as I mentioned, usually it's different from one industry to one industry, and one, for example, manufacturing different than service, different than other countries. So my recommendation for this question that we have developed local questionnaire based on this 11 element based on the culture. If we talk about the training, are we ready? Are we have this virtual training and electronic training system? So I believe I can share with you after the session one or two questionnaire, but my recommendation to adapt this questionnaire to cope with this or your organization. I have one questionnaire is like readiness for Lean 4.0. I can share, but I encourage you to customize for your organization based on your culture, of course, and your performance.
That's amazing. We would love to receive that assessment questionnaire, JD. But definitely, as mentioned by our speaker, it has to be tailored with the culture of your organization so that it makes sense for your organization. All right. So we have another question in here from Rafi Placido. Placido. What are the challenges that we need to prepare if this framework will be implemented in an electronics manufacturing industry?
So for Rafi, for me, the most challenging and for the most critical and the risk is the cybersecurity. And when we start to implement and have the strategy, I believe we need to have this budget and strategy for cyber security because many practitioners, even on functional level, are very willing for digitalization. And this may lead to data leak or some sensitive information leak, or even the system is hacked and completely stopped and hacked by this kind. So I believe cybersecurity is the main challenge and should be considered in the beginning as one of the high risk for, and we need to be ready with mitigation plan.
Thank you for that, Shady. I can see a lot of cybersecurity reports and news from around the globe, the different types of attacks, right? And it's actually impacting negatively from revenue of the organization from around the globe. So thank you so much for that. I think this is the last question that I can see in here from the chat box from Ricky Shrabang. Excellent presentation, Dr. Safti. You presented 7 types of ways to apply to Lean Manufacturing 4.0. My question is, why isn't the unused talent, which is another type of waste, not included in manufacturing, Lean Manufacturing 4.0?
I can say this is not a question, this is a recommendation, and it's very valuable
Yeah.
recommendation. And I was reading the question, and I believe I can add in my next slides that we need to also define. And in many organizations, we have some colleagues are very talented, are not used. So of course, there is a lot of HR tools for performance management, talent preparation, and talent assessment. I believe, thank you so much for this recommendation. I can add in my next slide. And this how I talk in the beginning, that this kind of session we learn from each other, and this how also we evolve as a leader and practitioner. Thank you so much.
Absolutely. Thank you for that, Ricky. So it will become 8 types of waste in the next presentation of Shady. Okay, one last question in here, by the way, Shady, from Romeo Posada. What approach?
Please.
Hi, he's one of my friends, Dr. Romeo Posada. What approach can be best applied for a labor-intensive manufacturing sort of reactive approach into how we can turn them into analytical or problem-solving people? Proactive approach to adapt lean manufacturing 4.0.
I talk about from my personal experience, Romeo Basada, recognition system. Recognition system is very important. When I talk, if you remember my presentation, I talk about people is the first pillar in any lean system. People involvement is one of the foundation for any strong recognition system for individual excellence and for team excellence. So my recommendation for you, for example, if we need to start this system, you need to have like monthly award or monthly recognition for the best implementation for one of the lean 4.0 tools, for example, the fastest implementation or the most effective. And this how we can engage and motivate our task force, especially as you mentioned in labor intensive. In labor intensive, we need to rely on the team through strong motivation and strong recognition system. And now I see many organizations have very strong recognition systems through mobile app. So your manager can recognize you in the app, anyone can see you, and you can start to collect some point. At the end of the month, you can transfer this point into cash. You can go to your family and buy some gift. So I think this is one of the effective recognition, and how we use digitalization before we can deliver some certificate, some cash money or gift. But if you use this recognition system, and we link this recognition system to performance management, it's linked together how many points you take in recognition can be added into your performance management. It will be very motivation. And if you implement, please share with me later on the results.
Wow. That's actually amazing, Shady, from rewards and recognition perspective. If it's tied up to the scorecard, and I can see some of our organizations that are gamifying the system as well to accelerate the adoption of the employees into the Lean 4.0 emerging technologies. That's amazing.
And Ray, if I need to add something, when you talk about this kind of game challenge or something, now when we have like some knowledge test, what we are doing now with our team, we make similar like what you say, some virtual game, and people in their mobile app can put the answer, and this is how we make the competition for the team, but from knowledge perspective. So everyone is very excited. This is not traditional pen and paper test or something like that. So people always excited, and this is not easy job to keep your team excited, challenged, and motivated. This is the challenging part of the business.
That's so true. Thank you for that, Shady. Oh, one last question, because this is one of my good friends, and he was one of the trustees of the Philippine Society for Quality, and is now with Philippine Airlines. This is his question. Hi, Sir Ronald. In lean manufacturing, how does support groups, say for instance accounting or logistics, can cope or go hand in hand with lean manufacturing 4.0?
So Ronaldo, if you remember the second slide, when I talk about the future factory, we have something called Logistic 4.0, where we can track, and you can see even on personal level, when you talk with DHL or FedEx on this kind of logistic company, through your app, you can track your shipment. And this help us to make some accurate receiving in the manufacturing facility. So we don't talk on phone anymore or check our emails. We can track live our shipment minute by minute, and this will help us to prepare the car and forklift and all this operational stuff within the plant, and to have this what we call window delivery and very accurate delivery. For logistics, I believe no issue. But for accounting, I think the early involvement, and I believe this group is not, I can say, no offense, is not 100% engaged still in the Lean 4.0. And also this good recommendation from you, and I need to add in my next slide, that we include accounting and finance team in this kind of implementation. And this what's good about OPEX. And usually in OPEX project and also some Six Sigma, they have some representative from finance in the project to ensure that the saving is real saving, and they need to approve. I believe we need to bring this accounting and finance people in the early beginning of the implementation. So this also, I cannot say is a question, is also good recommendation for me. Thank you, Ronaldo. Thank you so much.
Shady, I would agree that in most of our projects, especially from Lean Six Sigma perspective, that we invite the finance and accounting to validate all of the benefits that we're trying to present in there. All right, so I believe that's all of the questions that we have in here. So thank you so much, my dear friend Shady, for your time. Great insights, definitely that we got from the entire presentation. And before we let you go, I would want to present with you the certificate of appreciation. The certificate is awarded to Shady L. SHAFTY for imparting valuable insights and inspiration to the participants during the Lean Manufacturing 4.0 mini virtual summit on June 25, 2021, signed by the president of the Philippine Society for Quality. So thank you so much, and you stay safe,
Thank you.
my dear friend.
You are motivating me. Thank you so much. Thank you for the whole team.
All right, so thank you so much. So let me check again our chat box for. I mean, at this point, I can see more from Malaysia at this point who are logging in, and they are all ready for our next speaker. Let me. Can you type in number 52 in the chat box if you're ready for our next speaker? 52, because this is our 52nd year, the Philippine Society for Quality 52nd year of existence. Can I see all of the 52 right here, the chat box? All right, I can see some 52 comments in there. So before I introduce with you our next speaker, fresh from Malaysia, let me play this very short teaser for the National Quality Forum, which will happen on October 15th. All right, so let me present with you our next speaker to talk about the geometric dimensioning and tolerancing. So he's an expert from that perspective. Our next speaker currently works as a senior lecturer at the Faculty of Mechanical Engineering Technology at the Universiti Malaysia, Perlis. His highest qualification is PhD in manufacturing engineering at the University of Malaysia, Perlis. Before he became an academic, Dr. Iqbal's worked at Milat Tractors Limited. This is a leading and progressive organization in automobile sector of Pakistan, engaged in the manufacturing of agricultural tractors and machinery. I can also see in here that he also worked on gear metrology, spur, and helical gear quality checking on double flank gear roll tester. Those are some of the technical terms. I actually don't understand some of those terms. And in the academia, he carries out teaching, research, and consultancy duties. Our speaker's publication list covers many aspects of manufacturing and total quality management. He reviews numerous research proposals, undergraduate and postgraduate theses, and research papers submitted to conferences and journals. In his teaching capacity, our speaker guides more than 100 students at any one time. He specializes in manufacturing technology and total quality management. He teaches classes on management and control of quality, manufacturing systems, quality system, lean manufacturing, engineering analysis, operations management, manufacturing technology, industrial engineering, and a lot more. So, with over 30 years of academic and industrial experience under his belt, our speaker is often invited to conduct training programs in topics such as failure mode and defects analysis, or the FIMEA, control charts, Six Sigma, lean manufacturing, and he has membership of from professional bodies such as the Industrial Engineering and Operations Management Society. All right, so there's a lot more. He has great credential, similar with our first speaker, to talk about the geometric dimensioning and tolerancing. Our next speaker is no other than Dr. Muhammad Iqbal Hussain. Hi, Dr. Iqbal.
Yeah. Hello, how are you, Dr. Ray? Thank you very
Great.
much. Thank you very much. How is my voice? Did you hear me clearly?
Loud and clear. I can hear you, Dr. Iqbal.
That's great. That's great. So thank you very much for the nice introduction, Dr. Ray. I would like to welcome to everyone. So I'm glad to be here to share my technical know-how and experience on the subject GD&T, right? So I guess we're going to start the topic. So before going to the topic, I would like to say that GD&T is a very complex subject, and I can't do it justice to the subject in a 1 hour time, right? So I will be only to share the overview of the GD&T. So let me share my screen. Can you see the PowerPoint presentation? Hello.
See it now, Dr. Iqbal.
Can you see the PowerPoint presentation?
Yes, yes.
Okay. Thank you very much once again. So our today topic is geometric dimensioning and tolerancing, GD&T. So I would like to go through the presentation contents, right? So I would like to spend some time on the introducing geometric dimensioning and tolerancing. So we will also talk about and try to understand what is GD&T. Number 3, where does GD&T come from? Why geometric dimensioning and tolerancing is important so far as manufacturing is concerned. So we will also try to understand some GD&T terminology. So we will also see some examples of the GD&T terminology. We will also talk about tolerance. I will also share some ANSI, ASME revisions, right? So the second last subtopic will be GD&T advantages, and the last is references, right? Introducing geometric dimensioning and tolerancing, GD&T, right? when the typical hobbyist, right? I would like to spend some time to develop the background, right? Because I know some of the people, they have already background of GDT and some people may not. So for both of them, I would like to spend a few minutes to develop the background of GDT in order to understand this difficult subject. When someone need a simple part, right? For example, straight dowel pin, washer, are not for a particular or typical project, so he will definitely go straight to the lathe machine or milling machine in order to produce this product in a short period of time. Although the same person might be a designer, manufacturer, and also quality inspector at the same time. But however, this is a very key point to understand. However, in case of commercial manufacturing, right, or interchangeable manufacturing, right, interchangeable manufacturing means the production of parts to such a degree of accuracy as the necessary to permit assembly and proper functioning of the parts without further machining, fitting, and rework. However, in case of commercial manufacturing, the designer, the manufacturer, and quality inspector are rarely, hardly the same person, and may even work at different companies, at different locations, and in different countries, and performing their typical task. That is why the designer should design the product by creating an ideal assembly where all the parts, when assembled together, fit together at optimal assembly, optimal tightness and clearance and allowance. So he must convey to each part's manufacturer the ideal size and shapes or nominal dimension of all part surfaces. However, if multiple components will be made, the designer should recognize it's impossible to make them all identical. All very difficult to make all parts identical, right? So definitely we will get some deviation. So deviation or variation in the manufacturing process are part and parcel of each other. We can minimize, we can minimize, but very difficult to eliminate and eradicate variation from the manufacturing processes, right? So every manufacturing process has unavoidable variation that impart corresponding variation to the manufactured parts. The designer must analyze his complete assembly of blueprint or component drawings and assess for each surface of each part how much variation can be allowed in terms of size, in terms of form, in terms of orientation, and in terms of location of the part, where the part ultimately has to be assembled. Then, in addition to the ideal part geometry, he must communicate to the manufacturer the calculated magnitude of variation or tolerance each characteristics can have and still contribute to a workable assembly. For all this needed, right? For all this needed for design people, for production people, and for quality people. And if they are at different locations, different countries, different points, so the designer must communicate. For all this, we need to communicate. Words are usually inadequate to communicate. For example, a note on the engineering drawing saying, make this surface real flat, only has meaning where all concerned parties can do the following. First, they have to understand the note written on the engineering drawing. Second, to understand which surface the note applies and the extent of the surface. And thirdly, agree on what flat means. All are unambiguous, and it takes a lot of efforts to understand the conventional engineering drawing, not using geometric dimensioning and tolerancing. So agree on exactly how flat is real flat, how much flatness is required. All this we need to search, find, and identify from the blueprint, from the conventional blueprint. So throughout the 20th century, a specialized language based on graphical representation and math has evolved, developed to improve this communication gap, right? The gap between the product designer, the gap between the production people, the gap between the quality people, right? And even the end user of the product as well. He is also the stakeholder of the product. Has evolved to improve communication. So in its current form, the language is recognized throughout the world, which is known as geometric dimensioning and tolerancing, GD&T. That language wipe out the gap of communication between and among the designer, manufacturer, and inspector for the commercial manufacturing of components. And interchangeable manufacturing mean if the part is manufactured in one country of the world, can be assembled in any part of the country. That is why we have new products every day. That's why we have a short life cycle of the products, right? Due to the application of GD&T, right? So can we go through and to understand what is GD&T, right? The G, the alphabet G in GDT refers to geometric forms. The form can be plane, can be circle, can be cylinder, can be square, can be hexagon, can be spherical, can be rectangular. So these are the all geometrical forms, right? So theoretical, these forms are in their perfect form. In GDT, the limits of real variation tolerance are specified by the diameter, width of planar, cylindrical, annular, ring shape, or spherical zone. Geometric dimensioning and tolerancing is a language for communicating engineering drawing specification. GDT includes all the symbols, definition, mathematical formulas, and application rules, which are very necessary to embody a viable engineering language. As its name implies, it conveys both the nominal dimension, ideal geometry, and the tolerance for a part, since GDT is expressed using line drawings, symbols, and Arabic numerals. People everywhere can read, write, and understand it, regardless of their native languages. It is now the predominant language used worldwide, as well as the standard language approved by American Society of Mechanical Engineers, ASME, the American National Standards, and International Organization for Standardization, ISO, ANSI, the United States Department of Defense, and ISO, the International Organization for Standardization. Okay, from this diagram, I would like to highlight these are the three areas, right, where the application of GD&T is mandatory, right, at products design stage, production stage, and as well as quality control stage. Let me explain more in the next slide. So when we say engineering design, mean the designer must know what is to be manufactured. That is why then he can able to develop the design from quest for production, quality, and efficiency. And at the early tolerance port, design basic function, right? Second, product. What has been manufactured, right? Mean a product, the production people must understand the GD&T requirements, the GD&T specification, which are specified on the engineering drawing and which are mandatory for the manufacturer. For the manufacturer, in the coming slides, I would like to explain more on this. And the third, third is a part inspection, right? So how to do the inspection, online inspection, offline inspection. So in order to ensure at each stage of the product is manufactured, be following geometric dimensioning and tolerancing rules and regulations, right? So we can ensure the part most economically and effective production, right? Because now the manufacturing is very challenging, right? It's not easy to compete to the world, right? So that is why those companies who take care of their processes, take care of their the tools and quality tools and techniques and the GD&T, that is why if they have to encounter less number of defects, less number of rejects, right, due to the application of GD&T and other techniques, right? So, okay, can we go through where does GD&T come from? So in the 1800, manufacturing used the cut and try, file, and fit approach. Cut, try, file, and approach. Can you allow me to spend a few minutes on this, right? I would like to share with you my real shop floor experience, right? I think it during 1985, right? So my responsibility was to ensure the incoming quality of the components, right? Because I was working in one of the largest automobile company of the Pakistan. So we have more than 400 national and international suppliers. So we have a quality department. There are a few quality control, quality assurance, and quality audits, right? So my responsibility was to ensure the incoming quality of the products, right? So 1985, these vendors, what do they do, right? For example, supplier A is manufacturing a nut and supplier B is manufacturing bolt, right? So supplier A, he is keeping the bolt, right? And when he manufactures nut, so he just use the product in order to check the quality of the product, right? So when he bring the supply to the company, right, when we check, right, we find a lot of discrepancies, and we try our best to educate them in a way, right? So for example, they're manufacturing a nut, right? So we list down what are the gauges are required. For example, nut, we need, internal, in order to check the thread, we need a thread plug gauge, right? So we arranged a thread plug gauge for the vendor, and we asked them, you are the owner of this plug gauge, but we are going to purchase for you this plug gauge. You go and keep on your process, and when you are manufacturing a nut, you check the quality of on so that the product should reach to the company a reliable and perfect product, right? And how can we cover the cost from you? So we will cut a small amount of money from your bill, right? So the manufacturer, our supplier, become very happy, right? Very happy to. So in this way, we apply this on all our 400 suppliers, and now they have, they are technically they are so stable, so uplifted. So that's why now the company has no need to do 100% inspection, maybe random inspection, and give feedback. So in this way, the company save the time and similarly educate the supplier and uplifted their technical know-how and skill. And that is why in final product, we have increased our productivity. And I think our 1 year production was from 40,000 tractors per year to 60,000 tractors. So in this way, we educated our supplier and increased the productivity, right? So in the 18th, right, the manufacturing used cut and dry, file and fit approach, right? So this is how we eradicate this problem on our production and assembly process, right? So the plus minus coordinate system of tolerancing was next developed. So in the 1900, the first GD&T standard came out to improve the quality and utility of engineering drawing, right? In 1966, the United GD&T standard was published, ANSI Y14.5M, and the latest version, the current standard preceded by ASME Y14.5209 is now Y14.52018 is the current standard for GD&T. So why geometric dimensioning tolerancing is important, right? To learn how to effectively tolerance parts such that the part function correctly. There should be no fitting problem on the assembly line. You imagine if we have a car assembly plant and we have a lead time and we have given time to the customer, and due to a small washer, if it is below from the specs, the whole production line will be stopped, right? So that is why we need to ensure each and every part before going to the assembly line should be a perfect quality and according to the specification written by the designer on the engineering drawing, right? So fabrication cost is kept to a minimum due to observe effectively geometric dimensioning and tolerance, right? So apply geometric dimensioning and tolerance, in particular, the feature of the product. The feature could be position, the feature could be size, could be flatness, could be circularity, could be perpendicularity and parallelism. Some GD&T terminology. So let me go through and spend some time to understand the terminologies of GD&T, right? Use standard symbols to indicate tolerance that are based on the feature geometry, sometimes called feature-based dimensioning and tolerancing. Feature control frame is one of the features of the GD&T, which is very commonly used on engineering drawing, right? Or I can say the state of the art for tolerance. I would like to make you understand about the compartments that make up the feature control frame, right? So what is the feature control frame? If we look, it looks like a rectangular box, right? That contains a geometric symbol, modifiers, and datum reference. It has compartments, right? If we start from the left side, you can see the geometric control symbol, and the symbol is indicating some characteristics, right? And that symbol is showing the position. The second you can see is 0.025 indicates the tolerance of the position. M stands for tolerance modifier. And primary datum reference, A is a primary datum, B is secondary datum, and tertiary, C is a tertiary datum, right? So factors that determine the performance of a manufactured product other than mechanical and physical property includes, right? You can see a lot of papers and a lot of literature on the material properties of the product, right? And very few literature on the process, right? So that is why we not only look at the one aspect of the product, that is material, we should also look at the other aspect of the product if we have some problem, production problem and issues on the production line. So let me understand what is a dimension. Dimension is a linear or angular size of a component or a part specified on the engineering part drawing. Tolerance means allowable variation from the specified part dimension that are allowable in the part manufacturing line. A dimension is a numerical value expressed in appropriate units of measure and indicated on a drawing and in other documents along with lines, symbol, and notes to define the size or geometric characteristic or both of a part or part feature. Right? The dimension indicates the part size desired by the designer, and if the part could be made with no errors or variation in the fabrication process is allowed, right? Example of dimension. For example, the dimension of a rectangular part are 4 meters or in time 2m implies that the length of a rectangular part is 4m and its width is 2m. That is a dimension. Basic size. What is the basic size? The term basic size refers to the size from which the limits of size are derived by the application of tolerance. That is upper and lower deviation. The basic size or nominal size of a part is often the same and it is termed as zero line. The size used when the nominal size is converted to the decimal and from which deviation are made to produce limit dimension. For example, 0.8750 inch shaft, which is the basic size of a 7 by 8 inch nominal shaft size. Here is the example to understand the basic size, upper limit, lower limit, and tolerance, right? For example, here, the basic size is 25.00 mm. And the tolerance you can see is minus 0.10, and another tolerance is minus 0.20, right? Now we can make the limits, right, from the basic size and by subtracting the tolerance. So after subtracting 0.10 from 25, so upper limit will be 24.90 and lower limit will be 24.80 after minusing 0.20, right? And the tolerance is 0.10, right? So here we can also generate our definition of tolerance. Tolerance means the deviation between upper limit and lower limit is called tolerance. I hope you understand it. Nominal size. Let me allow to spend a few minutes on the nominal size. Nominal size is the size used for general description. The term nominal size refers to the size of a part specified in the drawing for convenience to shaft load. Example, 7 by 8 inch shaft or 25 mm shaft, etc. is a nominal size. What is the actual size? The term actual size refers to the actual measured dimension of a part, right? The difference between basic and actual size should not exceed a certain limit. For example, the size specified on the engineering drawing of a component when the component is manufactured. Now we need to ensure and verify whether the component is manufactured as per the required specification or not. So we will compare, we will measure the actual size with vernier caliper, micrometer, or with other precision measuring instrument. We will get some reading, right? So that dimension we now need to compare with the standard dimension. And if the deviation within the control limits, the part is okay, fine. But if the part is component, the actual dimensions are not meeting the requirement of specification, the component will straight away rejected, right? Feature. What is a feature? In GD&T, we need to understand these terminology, otherwise we cannot understand GD&T. Feature. So that is a very general term used in GD&T, right? It applies to a physical portion of a part, such as surface, hole, slot, length, width, depth, slot thickness, and so on. Feature of size. So cylindrical or spherical surface or a set of parallel surfaces associated with the size dimension can be external or can be internal. I would like to show you the picture of in order to make more understand. Location dimension locates the center line or center plane of a part. Feature relative to another part feature, center line or datum. Here you can see this diagram in order to understand feature of size. So here we can see we have feature A, feature B, feature C, feature D, and feature E, right? So feature A is the length of the rectangle, B is the width of the rectangle, and C is the center from the center of the hole to the left face of the rectangle. And dimension D is the center line from the whole center line to the opposite of the A plane, right? And E feature explain the diameter, right? So feature of size. So any cylindrical or spherical surface or a set of two opposed parallel surfaces associated with the size dimension. The dimension could be internal and the dimension could be external. Okay, so let me try to understand tolerance, right? tolerance is a very, very important feature in GD&T, right? As I have earlier explained to you from the example, tolerance means the deviation between upper limit and lower limit, that is called tolerance. So here we have a standard deviation which came from some standard. The total amount by which a specific dimension is permitted to vary. The tolerance is difference between the maximum and minimum limits. Variation occurs in any manufacturing process which are manifested as variation in part size. So tolerance are used to define the limits of the allowed variation, which are permitted by the designer. So precision is the degree of accuracy necessary to ensure the functioning of a part as intended. There should be no subsequent operation after the completion of a product. There's no subsequent rework. There's no subsequent milling. There should be no subsequent grinding, because all these involve cost, right? Cost. So each and every step we need to very, very careful about the quality of the product and the required specification of that particular product. So the tolerance is allowable variation for any given size in order to achieve a proper function. Tolerance equals to difference between lower and upper limit dimension. For example, we have upper limit and lower limit here. Lower limit is 0.500 inch and upper limit is 0.506. If we do some math, and we can see here the difference between upper and lower limit is 0.006 inch. So 0.6 inch is the tolerance, right? Here we have another example of, the tolerance. So here is another example of the tolerance, right? So tolerance zone, right? It's very important. So all geometrical tolerances have imaginary tolerance zone that are the basis for acceptance, rejection of the product. So have specific shapes depending on the geometrical tolerance and feature being controlled. Actual local size, the value of any individual distance at any cross section of a feature of a size, FOS. So here you can see the tolerance zones, right? The orange color is highlighted, right? If you look at the left side, we have a hole, and right side we have a shaft. So you can see here the minimum size, maximum size, upper deviation and lower deviation, and then allowance, tolerance. So, and you can here, this drawing also shows us the minimum size, how much minimum size of the shaft the manufacturer has to manufacture, how much is the maximum size for the manufacturer, and similarly, how much the minimum size for the hole and maximum size for the hole, so that we can have a hole and shaft fit system can be achieved, whether we have an interference fit, whether we have a transition fit or a clearance fit, right? It depends, right? If we have clearance fit, so we have to manufacture the component of shaft and hole as per the clearance fit. Similarly, the interference fit and transition fit, right? Why is tolerancing necessary, right? So this one, as I have already highlighted, today is the, for example, for a large scale company, right? But particularly the automobile company, right? They cannot manufacture all the parts by himself in order to develop the in-house manufacturing. Not possible. It's not cost effective, right? So that is why interchangeable manufacturing is very, very important, right? So that is why for interchangeable manufacturing, the GD&T plays very important role, right? In order to smart manufacturing, right? So it is impossible to manufacture a part to an exact size or geometry, right? So assemblies, right? Parts will often not fit together if their dimensions do not fall within a certain range of values, right? I have already highlighted the importance of, by giving you the example of washer, right? Washer is a very, very common component used in the automobile assembly, right? Even where we have a small deviation of the washer, right? You can see in automobile thousands of components, and small washer is out of specification that can stop the production, right? Whole production. And in today's manufacture, we cannot afford WIP, work in progress. Not possible. That is why we were just in time and all these techniques in order to avoid all these kind of things, right? So GD&T also plays very important role to manufacture the part first time right component, right? So tolerances are needed to control the dimension of any two mating parts so that any two parts can be interchangeable, right? So tolerances on parts contribute to the expense of part, right? The smaller the tolerance, the more expensive of the part being, because we have to purchase very precision machinery to manufacture the component, precision miring and test equipment to ensure the quality of the product, right? So that is why GD&T highlights how much tolerance is required, how much the limits are allowable, right? So based on that, we can arrange our facility in order to manufacture the product. So Kate, types of tolerance, right? So dimensioning tolerance, geometric tolerance, right? So geometric tolerance, right? The total amount of a specific dimension is permitted to vary, which is the difference between maximum and minimum permitted limit. Geometric tolerances deal with the geometric forms of the components, right? Here we have some example of dimensional tolerance here, right? So these figures indicates, right, how to write the angular dimension on the engineering drawing, right? So angular size dimensioning tolerance, curve dimensional tolerance, diameter dimensioning tolerance, right? And then we have radial dimension. You can see here how to indicate the radial dimensioning tolerance on the engineering drawing, right? Similarly, if we have a locational dimensioning tolerance, for example, from one face of the component to the another face, how to write the tolerance on engineering drawing, right? So you can see here, X is the distance required, and then you can see plus minus tolerance, right? So why this is plus minus tolerance, I will explain in my in the coming slides. So then angular dimension tolerance, right? How to write angular dimension on the engineering drawing, right? So here we have some more examples with reference to the angular tolerance, right? For example, I will start from the left, right? So this is a 45 degree, 44.72 degree, and 30 degree, 15 minutes, 25 degree, 10 minutes, 30 seconds, 0 degree, 0 minutes, 30 seconds. This is how can we write the angular dimension, angular tolerance on the engineering drawing, right? How is tolerance specified, right? So this is very important slide, right? Let we try to understand what is a general tolerance, right? A note may be placed on the part engineering drawing which specifies the tolerance for all dimensions except where individually specified. For example, we can find this tolerance I'm talking about conventional drawing, right? But now this is wiped out in the by application of GD&T, right? For example, all decimal dimensions to be held to plus minus 0.020. For example, in conventional engineering drawing of the component, if we find this note, right, any of the dimension which is the decimal dimension, mean, for example, 10.0, mean 0.0 is a decimal dimension. 10 is not decimal dimension, right? So if we have a dimension, for example, 10.00, so this kind of dimension, the tolerance will apply plus minus 0.020, right? So another note we can have, for example, all dimension without decimal dimension, the tolerance will be applied plus minus 0.25. For example, other than the decimal dimension on engineering drawing, so the tolerance will be plus minus 0.25. So what are the specific tolerances, right? What are the specific tolerances? The tolerance for a single dimension may be specified with a dimension based on one of the following methods, right? It could be unilateral tolerance, bilateral tolerance, and limit of dimension. So I want to spend a few minutes to make you understand the difference between unilateral, bilateral, and limits of dimension, right? So unilateral tolerance system, right? In this type of system, the part dimension is allowed to vary on one side of the basic size, right? That is either below or above. This system is preferred in an interchangeable manufacturing, right, environment. This is because it is easy and simple to determine variation. This system helps standardize the go gauge end, right? This type of tolerancing method is helpful for the operator as he has to machine the upper limit. Here is the example. For example, you can see from this diagram, the nominal size is 2.500, and you can see here the tolerance is plus 0.01 and minus is 0.00, right? It means we can move towards the plus side. Mean the operator can manufacture 2.500 or 2.501. So this tolerance does not allow us to go below from the 2.5. So that is a unilateral tolerance. So another type of system is a bilateral. Bi means two-dimensional tolerance, right? So in this system, the dimension of part is allowed to vary in both direction of the basic size. So limits of the tolerance lies on either side of the basic size. Using this tolerance, as tolerance are varied, the type of fits gets varied. When a machine is set for a basic size of the part, then for mass production. So here is the example of bilateral tolerance, right? For example, 2.5. So the manufacturer can have a bilateral tolerance. He can go positive, and as well as he can go also minus, right? So plus 0.005 and minus 0.005. So that type of tolerance, that form of tolerance is a bilateral tolerance system, right? I do hope you understand the unilateral tolerance systems and bilateral tolerance systems, right? And the third type is a limit dimension, right? So here the two limits are given, upper limit and lower limit. Here there is no plus tolerance, no minus tolerance. Here the limits is given. For example, the upper limit to 2.505 and the lower limit is 2.495. So that type of tolerance is called limit dimension, right? So here I would like to share some standards deals with tolerance. And for academic people, this is very important. And even the people who are working in the industry are also can get the help from these standards, right? Which are deals with the tolerance, right? And with the GD&T, right? So tolerance is just like written languages, as we have discussed earlier. It has its own standards. There are too many standards like ANSI, inch system, ISO metric system. So list of standard, for example, ANSI B4.1 deals with the tolerance. ANSI B4.2 also deals with the tolerance. ISO 286, ISO 1829, ISO 2768, and European standard EN 20286 also deal with the tolerance. And JIS, right? JIS, Japanese Industrial Standard, also deal with the tolerance, right? And BS 969, British Standard, is also in a tolerance system, right? So I would like to little bit explain about BS, the importance of BS 969. So BS 696 is a British standard. So it provides the specification for limits and tolerance on plain limit gauges, right? Plain limit gauges such as if we want to design a plug gauge, snap gauge, gap gauge, ring gauge, depth gauge. So these are called limit gauges, and these are very much commonly used on the machining project, machining lines, right? If we are manufacturing and doing machining on the engine block, right, or cylinder head, or center housing and transmission gear and other major components of the automobile. So these limit gauges plays very important role to ensure the quality of the product, right? So BS 969 specifies gauge tolerance for workpiece tolerance in the range between 0.009 to 3.200, right? It means if the workpiece tolerance means that if the deviation of upper limit and lower limit is minimum is a 0.009 to 3.20, then we can design the gauge, right? But on the other hand, if the deviation between upper limit and lower limit, the deviation is less than 0.009, then it shows that your component is very prescient. And for this component, you have to go for higher level of prescient component. For example, coordinate measuring machine, CMM, or UMM, universal measuring machine, or other high prescient components, right? But on the other hand, if the deviation between upper limit and lower limit is maximum 3.200 mm, so still we can design the gauge, right? But if the deviation is more than 3.2, then there's no need to design the limit gauge, plug gauge, snap gauge, or other gap gauges. So we can use the steel rule or inch tape in order to check the component, right? So that is the importance of 969, right? So in an assembly process, the degree of clearance or tightness desired between mating part is very, very important, right? So here I would like to make you know about the actual mating envelope concept, also very much used in the GD&T, right? What is envelope concept mean? For example, a similar perfect feature counterpart that can be circumscribed, inscribed about within the feature. So it just contacts the surfaces at the highest and the low point. So it is derived from actual part. So used when we are calculating a bonus tolerance, right? So here I'm going to show you some from this diagram. I would like to highlight the envelope principle concept, right? So proper tolerancing establish the envelope of the perfect part. Any deviation in form is acceptable as long as it remain within the limits of size. Right? You can see here required specification of the rectangle, right? The upper limit and the lower, the red line. And the blue line indicates the actual dimension of the component, right? Although there is a deviation, the shape of the actual component after manufacturing, right? So we can see from this diagram. So the blue line, right? Although it does not going beyond the upper limit and the lower limit, right? It is within the control limit, so that is acceptable. But still there is a deviation. This indicates and give warning to the manufacturing people. You have to minimize this variation in order to you can see the blue line almost touching the upper limit and lower limit boundary, right? The tolerance zone. So that is a warning for the manufacturer. Reduce the variation from your product, right? So here we have another example of. Okay, yes, sorry. I would like to highlight another two important terminology, LMC and MMC. In GD&T, for example, in quality control, we use the upper spec limit and lower spec limit, but in GD&T, these are replaced with the terminology LMC mean least material condition, and MMC means maximum material condition. Least material condition is a lower limit, and MMC maximum material condition indicates the upper control limit, right? So here we have another diagram. So here we can see LMC, least material condition, and maximum material condition. And we can see here also the clearance, right, between the LMC and MMC, right? So limit of size at X section, right? For example, we have a shaft, right? So the shaft is, say, 300 mm length, right? So we have a specific diameter. So it means throughout the 300 mm length, the diameter should be even, right? Should be even, should be according to the requirement specification, should not be below and from the upper specs, right? So here, this diagram indicates, right? So when we complete our manufacturing and we want to check our manufactured parts, right? So it could be take these four situations, right? The component could be bored, can be wasted, can be barreled, and can be a tapered form, right? So these are the actual four situations of the manufactured component. So in this slide, I'm going to highlight, revision, right? Some revision. The first revision of ANSI or GD&T standard, right, introduced in 1966. The second revision in 1973, and the third revision in 1982, fourth 1994, and the third revision is 2009. Now the current revision is the ASME Y4.5 208 dimensioning and tolerancing, right? So here we have some symbols of GD&T. So you can see a type of feature, type of tolerance and characteristics, right? For example, flatness, straightness, circularity, cylindricity, line of profile, and surface of profile, right? So perpendicularity, angularity, parallelism, circular runout, total runout, concentricity, position, symmetry. So these are the 14 characteristics that are very much used in GD&T, right? So I would like to show you a drawing that does not use GD&T. What are the problems we can encounter, right? If you look this figure 1.5, 1.1 drawing that does not use GD&T. You can see here, so this red line and also the arrow, right? So not well known, right? So it was important that the dia, right? You can see the mounting face, right? The mounting face diameter is 5.5. Bore should be perpendicular to the mounting face, but in this drawing we can't see, right? Maybe there is an additional some drawing or detailed drawing we have to explore in order to understand, right? For example, the operator has no much time to explore the drawing, right? It takes a lot of time, and its productivity can be suffered, right? So that is why conventional drawings are now replaced and changed with the GD&T, right, to make it more clear and understandable. If you look another feature here, the major diameter, which is the 11.00, if it were critical that the dia 5.5 bore and the dia 11.00, the outer diameter, to be the same axis, right? So from this drawing, we can't see they have the same axis, right? The same center line, right? We can't see, but all these things we can see. I'm going to show you our drawing using GD&T, right? So, for example, in this figure, it shows a non-GD&T drawing of an automobile wheel rotor, right? Despite its neat and uniform appearance, the drawing leaves many relationship between part features totally out of control. My apologies. The drawing leaves many relationship between part features totally out of control. For example, what if it were important that the dia 5.5 bore be perpendicular to the mounting face? What will be happen? Nothing on the drawing addressed there. What if it were critical that the dia 5.5 bore and the dia 11.00, the external diameter, the major diameter, the outer diameter, be on the same axis? So nothing on the drawing requires that either, right? So now I'm going to show you the drawing that uses GD&T, right? So you can see here, right? You just look the mounting diameter 5.5, right? So, and the major diameter of 11.11, 11.00, both diameters are the same center line, right? And you can see the feature control frame. We can see the symbol of perpendicularity, and also we can see the tolerance. We can also see the modifier, and also that dimension is with reference to datum A, right? So all details are given on the one page of drawing, right? No need to refer the additional drawings in order to know what is the tolerances are required, right? So that is the advantage, one of the advantage of GD&T over conventional drawing, right? So here is the detail of that figure. For example, here, figure 1.2, GD&T provides unique, unambiguous meanings for each control of the feature, precluding mean to make it impossible for each person having his own competing interpretation, right? So nobody can do his personal interpretation of the size and the tolerance of the feature. That what is written in the engineering drawing, it is mandatory, precluding for each person having his own interpretation, right? So GD&T then is simply a means of controlling surfaces more precisely and unambiguously, right? I'm going to very close to my the end of my presentation. So, and that is the fundamental reason for using GD&T, right? It gives us clarity. It gives us understanding, more detail about all the features required for that particular component, right? So it is a universal language throughout the world for communicating engineering design specification. Clear communication assures that manufactured parts will function and that functional part would not later be rejected due to some misunderstanding of the tolerance. So here we have some advantages of GD&T. So top companies like BMW, Caterpillar, General Electric, John Deere, Boeing, Rolls-Royce Motor Cars, and NASA use GD&T to specify how to control the function of complex design. So even the smallest companies who are engineering drawings will always require the ability to communicate geometric tolerances very clearly on their blueprints. To put it simply, if someone career or business involves reading, dimension, or creating engineering drawings or engineering parts drawing, one must need GD&T, right? So repeatability of part orientation through the use of datum features, easy calculation of worst meeting condition boundaries, one standard used by all who will create or interpret the engineering drawing, ease of part definition, geometric symbology, interchangeability, cylindrical tolerance zones, and here we have some references. So I have used these references and many more references in order to develop my presentation. So I would like to end my presentation with this note. We must drive productivity. We must increase our manufacturing productivity with the application of GD&T. So thank you all for attending this summit. Thank you very much, PSQ, for arranging the summit. Thank you very much, Dr. Ree. So thank you very much, MS Stein, for your help, support, and follow-up reminders that makes this presentation possible. Thank you.
Wow, that's an amazing presentation. Thank you so much, Dr. Iqbal. I can really sense a lot of expertise from that specific topic. So great job. I learned so much. Same thing that I learned from our first speaker. I can see a lot of encouraging comments in here from our participants that you're able to narrow down, you're able to simplify a very complex topic. So that's a great job. We have one question in here that I can see in the chat section, Dr. Iqbal. This is from Rafi Placido. The question is, why is GD&T necessary for first article inspection?
Yeah. So thank you very much. This is a great question, right? So GD&T is very important, right? Not only for production, not only for the final quality of the product, right? We have to take care of the quality of the product, right? Dimension of the product, right? Right from very beginning of the design of the product. So if we take care the GD&T right from the very beginning, concept of the design, and then the prototype and pilot production of the parts, right? Then final production, and then of course we will get a first time right product. I do hope I answered the question.
Product. That's amazing. Thank you so much for that, Dr. Iqbal. By the way, for all of our viewers, I encourage you to subscribe to our channel, the PSQ Nation channel, as well as follow our Facebook page so that you will be notified in all of the updates of the Philippine Society for Quality. We also have another question in here, Dr. Iqbal, from Matt Yulo. Do you know of any glass manufacturing company using GD&T for their bottle drawings?
So thank you very much for asking question. GD&T is not specific to the automobile, not specific to the sugar manufacturing, not specific to the steel manufacturing. It is very generic, right? Generic technique which is applicable to all type of manufacturing. Oh, so glass, is a very complex process. Is not simple. There's a lot of wastage, right, during the process, right. So that is why it's very much applicable in the to manufacture, right, particularly the glass manufacturing company, right. I have seen this process, right, when we are doing our, engineering, right. We visited one of the company, right, glass manufacturing company. So I saw these processes are very, very critical process, right. For example, I'm hearing holding this glass, right. It has a dimension, right, diameter, right. This wall thickness. You take care. For example, this wall thickness, if we not control, right, if it is less, it is not justice to the user, right. If it is excessive material, so we are wasting the material, right. So that is why GDT is very, very important, right, for glass manufacturing.
That's amazing. Thank you so much for that, Dr. Iqbal. Amazing answers as well as the entire presentation.
Thank you,
And by the
Dr.
way, thank you so much. And to all of our participants, we will be sending out the certificates when you respond to the survey that we will be flashing later on. And most probably, I'll be seeking the approval from our speakers if you can send a presentation to all of our participants in PDF format.
Okay,
And
can proceed, please.
absolutely, thank you so much for that, Dr. Iqbal. At this point, I don't see any question. I can see in here from Dr. Mohammed Khalid. Good job, Dr. Iqbal. I think Dr. Khalid is from Nigeria. So thank you so much for joining us. And at this point, let me present with you the certificate of appreciation to our dear speaker, to Dr. Muhammad Iqbal Hussain, for imparting valuable insights and inspiration to the participants during the Lean Manufacturing 4.0 Mini Virtual Summit on June 25, 2021. And that's signed by yours truly. And that's on behalf of the PSQ board. Thank you so much, Dr. Iqbal.
Thank
And
you.
thank you so much, and you stay safe. And at this point, let me flash in here the QR code for the survey. So I'm going to give you a few seconds to scan the QR code that's flashed on your screen. And we will be providing as well the feedback that we can get from this survey to our dear speakers, to Shady as well as to Dr. Iqbal. All right, so at this point in time, I just want to say thank you so much, everyone, for joining us. Thank you to our dear speakers. Thank you to Shady as well as from Dr. Iqbal. We learned so much. There's a lot of things that we will be taking away from this specific summit. You are so amazing, and please continue to collaborate with PSQ. And we look forward to working with both of you in the future learning events of the Philippine Society for Quality. So thank you so much, everyone, for joining our session for today. And please make sure to follow us on Facebook and LinkedIn, as well as in our YouTube channel, for you to get more notification or future notifications regarding the learning events that we will be facilitating or that we will be holding from PSQ perspective. Have a great day and stay safe, everyone.